Continuing 2.2, so when we get to secants, we say, look, that's an angle, and that's really -2 equal the secant of theta, right? It would be best to go to a cosine probably because students tend to see it better. And if I look at the reference angle, that is, the cosine of which angle gives me 1/2, cosine of pi over 3 is 1/2. I have a reference angle of pi over 3, and inverse cosine of secant is negative in quadrant 2. Remember that? So what is pi over 3 in the second quadrant? 2 pi over 3. So inverse sine, inverse tangent can either be pi over 3 or negative pi over 3. Inverse cosine or secant can only be pi over 3 or 2 pi over 3, either quadrant 1 or quadrant 2. Same deal with this problem. If you call this theta, you're really looking for -2 radical 3 over 3 equaling cosecant of theta, which means the sine of theta is actually 3 divided by -2 radical 3. You might not recognize this, but if you rationalize it, you'll recognize it quickly. That is actually -3 radical 3 over 2 times 3. Those 3's cancel out. And this is saying, where does the sine of theta equal -3 radical 3 over 2? And if I look for a reference angle, meaning I ignore the plus or minus, sine of pi over 3 is radical 3 over 2. So they're an excellent example. But if I'm talking about inverse sine, I know it can only be in quadrant 1 or quadrant 4. So what is pi 4 in negative rotation? That will be -pi over 4. Now the last aspect of this section is crucial. For calculus, this is a must. I'm looking at this and I'm thinking, well, I'm looking for a ratio. My answer is a ratio. I'm going to call this angle theta. You only allow the angle to be the trig function, nothing more. So I'm really looking for the sine of theta, which is the opposite over the hypotenuse. I go on the side. If I let theta equal the inverse cosine of u, that means cosine of theta equals u over 1. If I draw my triangle, the good part about these problems here is that unless they tell you otherwise, you assume that variable is in quadrant 1, so you assume that's always positive unless they tell you otherwise, and they won't. If this is theta, the adjacent over the hypotenuse, that makes this the square root of 1 minus u squared, and you want the sine, which is the opposite, over the hypotenuse. Number 60, if you call this angle theta, you're really looking for the tangent of theta, which is the opposite over the adjacent. On the side, you let theta equal the inverse cosine of u, so the cosine of theta equals u over 1, which is the adjacent over the hypotenuse again. You are still doing the same thing. It's right there, but we'll do it again for practice. We are in quadrant 1, and adjacent over hypotenuse, 1 squared equal y squared plus u squared. So y squared equal 1 minus u squared, and if you square both sides, in this quadrant it's positive, and you want the tangent, which is the opposite over the adjacent. The opposite is the square root of 1 minus u squared, and the adjacent is a u. And if I look at number 62, if I call this theta, I'm really looking for the sine of this angle theta, which I know is, as far as theta is concerned, the opposite over the hypotenuse. On the side, if I let theta equal the inverse cotan of u, that means cotan of theta equals u over 1. And if I draw my triangle, again, all of these variables, the beauty of them, they're all in quadrant 1 because we assume they're always positive. This is the adjacent over the opposite. That makes this the square root of 1 plus u squared. And I want sine, which is the opposite, over the hypotenuse. And if I look at number 64, if I call this theta, I'm really looking for the cosine of this angle theta, and I know that is the adjacent over the hypotenuse. On the side, I let theta equal the inverse secant of u, so secant of theta equals u over 1. I could draw my triangle. Cosine and secant go hand in hand. This is the hypotenuse over the adjacent. So the hypotenuse of this theta is u, the adjacent is 1. This is the square root of 1 minus u squared. And I want the cosine, which is the adjacent over the hypotenuse. And this is a problem from my calculus book. It says, prove that this is true. Work with the left-hand side. If I take the cosine, and if I call this theta, I'm looking for the cosine of theta, which is, as far as theta is concerned, the adjacent over the hypotenuse. If you let theta equal the inverse sine of x, that means sine of theta equal x over 1. My triangle is in quadrant 1. There's theta, and this is the opposite over the hypotenuse. That makes this the square root of 1 minus x squared. And cosine is the adjacent over the opposite, which is this. And there's your homework, and that concludes section 2.2.